Okay, we're back now for talk. I think we'll be finished here in about a half an hour or so. I'll be hanging around until 7 on the chat room if you like. An hour and a half is typically our more normal session duration. I think we've been pushing it hard for the last few weeks. One of the things you might have noticed in our labs is that you're encountering concepts perhaps a week in advance of the topics being discussed in the lectures themselves. That's, I would say, partly by design, that we like to expose you to physically and encode some concepts. Perhaps you wrestle a little bit with them, do a little bit of research on your own, and then we look at them in a bit more detail ourselves in the subsequent weeks' talks and lectures. A good example of that is exceptions. We've been seeing some of those this week, but Siobhan will be taking on a tour of exception handling in a bit more detail next week. Another example, though, is testing, and you did quite a bit of work on testing last week, and now we'd like to just review those tests and get a sense of what it is we were doing and perhaps also why we were doing it. Hopefully the project last week, it's a little bit challenging to see this now, but you were hopefully able to complete the tests, and you were able to, when you completed the lab, run all the unit tests as I'm just doing here. And you can see in this test runner here, we're getting our test results. These were indicated in the lab itself and in the various screenshots. So this ability to run tests inside our IDE very quickly, just pressing a button. These tests run very fast, getting immediate and instantaneous feedback. If we do have any issues in our tests, we're reporting back pretty quickly into our IDE here, the actual test failure conditions. So I'm running this test, and this time I expect to get an error. And here we're seeing the error occurring, and we're seeing exactly where the error has occurred here. Okay, what were those tests, and what kind of things are we testing? That's kind of what I'm going to look at in the next few minutes. So we're looking at the tests we've implemented in pacemaker, and obviously for your assignment you can take this test sequence we've built and I think work with it, augmenting it with additional features comparable with the features you're choosing to implement. In our tests, we've decided to mirror the structure of the project itself, building some tests for the core models, then building tests for our API, and keeping separate from our API test the test for the serializer. Serialization being, as you've seen from last week, quite an interesting and rather complex topic, which we're evolving separately and also testing separately. This is the model we created. We did this several weeks ago now, a user, an activity, a location, users of IDs, first name, last name, activities of IDs, type, location, distance, and our locations just have latitude and longitude. We're using an ID system here to keep count of the objects we've created. So we have a static counter we increment. Otherwise, the classes are straightforward implementations. We're using some helpers to implement the classes, in particular the toString, equals, and hash code implementations. These are needed really if our classes are data classes. This is what these are. And we're using standard formulas for implementing these. The tests for these classes, we find it convenient to introduce a set of fixtures independent of all our tests. So you'll have noticed from the lab last week, we have a fixtures class, and then we've got a set of users, set of activities, and set of locations we've created. 4 or 5 in each case, and each of those are designed to give us simple sanity tests for the models as we evolve them. Just making up some data and keeping it reasonably consistent. Here's our user test. We're testing create, we're testing our IDs, and we're testing that equals works. So the tests are very basic. In fact, they're almost trivial and perhaps not worth doing, because what are we testing here really? We're just testing that our data class works as expected. But if we're new to Java, and if we're new to perhaps using the Guava libraries to implement some of these features, then maybe it's not such a bad idea to use some of these, write simple tests like this. The second test we wrote is a bit more useful, I think. It's verifying that the ID system we have implemented works. Specifically, if we create a set of users and we add all those users to a set, are all those entries in the set unique? Remember, we discussed set a few weeks ago. When you put something into a set, it must be unique. There must be no more than one of them. And this test here is a very simple test to verify that all our keys are unique. Third test here then is to verify that our test equals works as expected. In particular, we're seeing if I create two users, Homer, there's one in the fixture and there's one created here in the class called Homer2, then I'm expecting those to be equal. I'm also expecting them to be not the same. They're two separate objects. And that's a test that's taking place down here at the end. So these probably aren't typical tests really. They're just tests that maybe we might write if we're new to Java, or if we're new, as I said, to implementing equals and to string and so on with the Guava libraries. And we're verifying more our understanding than necessarily the core features of those particular class libraries. Here's another test, the last one, test to string. So I'm testing explicitly, does the toString method work as I believe it should work? Again, it's probably a trivial test and maybe not really necessary, but it's useful for our purposes for the moment. Activity tests follows similar sort of pattern. We're just checking to see do the basic getters and setters work, and does our toString work? And similarly, our locations test is probably trivial. The locations here are coming in from our fixture. So we've got a fixture which got an array of locations we're using for this and some other tests. So we got all that working. Then we've got a nice control panel telling us that things are going okay. All our model tests should be working. In fact, we may have, if we were proceeding in a test first driven mode, built the models and tested them before we proceeded to the controllers. So test first would imply stable model, well tested in advance of any further development. That gives us a good bit more confidence as we move into the API implementation, and certainly we want those tests running before we went anywhere near implementing our serializers. Now, before we get into the API, last week one of the concepts we kind of threw at you was using optional classes, and we'll have something to say about optional and null safety later on, but we should visit it in a bit more detail now. Null pointer exceptions, or NPEs, have really plagued Java since its inception. In fact, not just Java struggles with null pointer violations. The family of languages that Java derives from, which goes back to ALGOL in the 60s through C, C++, all embody the concept of null, and they all cause a pretty serious breakdown when access to null is triggered inadvertently. The originator of ALGOL, in fact, Sir Tony Hoare, still alive, called it his billion-dollar mistake. He felt he shouldn't have incorporated null into that language, and of course it was copied many times since. Optional was developed as a class in the Guava library by Google, as a way to at least ameliorate some of the challenges of dealing with null. It's a simple enough concept, and you may have seen it last week. Perhaps you were a little bit puzzled by it. Hopefully we can explain it in a little bit more detail here now. It's a little bit vague in terms of how widely used you should consider making of it, because it is a little bit verbose and a little bit clunky. We'll be very interested to see in Kotlin in a few weeks' time how Kotlin takes on this problem, which we call null safety. And it's considerably more elegant than the optional solution we're looking at here. Here's it in action. Optional is effectively a framework, mini framework or class. We supply into an optional an object, and the object may be null, but optional itself is never null. And we explicitly ask the optional if the object it's encapsulating is capable of being null or not. And if it is null, it'll tell us can't have it. If it's not null, we'll get it out. Effectively, we're delegating to optional the null safety check. Here is the core of it here. Looking at it in more detail again, activities.get, that is one of the methods we've implemented a few weeks ago now. The purpose of this call here will be to retrieve from our collection a value at key ID, but this may be null. That is, the ID field may not exist in the activities collection. If that happens, the return value is a null, and if we dereference that null, we get an NPE or a crash. So we've replaced all of that code in our sample solution so far with the clause you're seeing here. That is, if it's capable of being null, stick it into an optional, and then ask the optional, is the value present or not? If it is present, we get a true, and then we retrieve from the optional the value by calling get. If you're confused by this, I'm not too surprised, because it is a little bit awkward, and you could feel free to not use that feature in your assignments if you felt it was troublesome. We put it in really to make a point that null safety is a weakness in the Java language, which is being grappled with by successor languages, and which Java coding practices themselves have had to adapt to in order to make Java a little bit more robust. And of course, optional has arrived into the core of the JDK itself. In fact, it's more or less been taken intact from the Google Guava library directly in, as you can see here. So we didn't actually need to include Guava. We could have used optional straight from the JDK. With that in mind, let's look at the API. API is the class we've invented to implement, we might call it our business logic, to implement our core features. It doesn't incorporate the user interface, so it's just implementing the management of our data structures, the logic of our app. Here is the implementation as we looked at it last week. We're maintaining a user index and an email index, which are holding the user information. And we're also maintaining an activity index to store and retrieve all the activities. These are general purpose indices available through our application, but of course our activities will also be contained in one-to-many relationships within each user. I won't read through this code in great detail. I think we've been looking at something like this now for a few weeks. We're able to retrieve users, delete individual user, create an activity here. So again, we're seeing the optional in action here. This is where we're putting an activity associated with a user into our data structures. And of course, the user itself retains the activity in his own data structure. Getting activity, adding locations. Again, I think you've seen some of this code now for a while. And that's as far as we'll take it for the moment. We're able to manage users and activities within users in this code. How do we test this? Well, we're building a brand new test, pacemaker API test. We are in our setup creating a pacemaker object and creating a range of users. So our fixture now is a little bit more sophisticated than the fixtures we had in the stack and video player example. We're going through a for loop and we're putting whatever number of users in our fixture, and we had I think 5 users there, straight into the pacemaker immediately we created. Then our tests are in the context of that fixture. So we have a simple test user whereby we are adding in a new user and we're verifying that our pacemaker object has got an extra user now, having inserted it. And down here, we're verifying that the users we inserted in our fixture setup are all present in the container. So we're again marching through the fixture and verifying that pacemaker contains all the users we think we inserted. Seems a little bit involved, but this is typical of the kinds of tests we should be writing. They're fairly exhaustive, verifying what seems to be very simple features of our API. Can I put users in? When I put them in, are they there? And if I put an extra one in, does the container grow by 1? Obviously, if we add stuff, we want to see if we can remove it. So here we're adding in a user, checking if a user exists and then deleting the user. And here we're verifying that we have actually removed the user from the collection. Then we proceed with a series of tests around the activities. So adding an activity here. So we're creating an activity. We're using some of the fixtures that we've already set up to define the activities we're creating. And once we insert them, we're verifying that we can get them back and that they are in fact the ones we inserted. Activities with locations here. Again, these tests look verbose, but they are necessary for the moment at least, according to the API we've established. Here we're creating an activity, adding a location. Then we're asking for the activity back, and we're verifying that the activity we get back is the one we inserted, particularly that it contains the locations we've added. And finally, a test that looks for adding multiple locations to an activity. Tests look rather verbose. We're relying heavily on the fixtures we established, which is set up a range of test data. And the tests themselves are quite explicit, and they seem to be testing rather obvious things, but that's the whole point. We're testing the basic features of the little subsystem we have established. In this example, we're seeing is Marge there. We're creating activity for Marge. We're adding a range of locations to that activity. Then we are checking to see, does the activity actually contain the locations we've added? With these tests in place, we're now in a good place really in terms of our pacemaker API implementation to evolve it further. For instance, bring in persistence, keep our activities and users in a database. Perhaps our activities and users may be held in a separate location. They're not, of course, at the moment. It's all very trivially implemented, but we've got a set of tests here now that enable us to think great thoughts and move the application forward at a later stage. Serializer, as you may have gathered from last week, is quite interesting to explore. And one of your story points in the assignment is to look at alternative serializers. So we better be able to test it if we're to have any hope of changing the serializer later. And in the solution we looked at last week, we introduced a serializer interface, which abstracts the notion of a serializer. So a general purpose serializer is something that we can push things onto, and then whatever we push down, we can write it all out. And then if we read it back in, we can pop off the things we wrote out. So it allows us to implement a fairly sophisticated object persistence mechanism. Here is how we implement it in our API. We have a load and a store. And these load and store functions write out everything or read in everything to the serializer, which is in charge of storing the object graph to whatever mechanism or persistence library it has chosen to implement. So for storing, we first push whatever objects that are of interest onto the serializer's stack. And then when we're happy that this is what we want to save, we call write. This will save our entire data structure set to the serializer. When we are wanting to load back from disk, we first issue a read to read the entire object graph. And then we recover each of the objects in the appropriate sequence that we push them onto in the serializer itself. So here we're recovering each of the data structures we may have saved. This is how we are using the serializer. The implementation of the serializer you explored last week. I was going to say it's simple code, but it's not really. It's a lot of work going on under the covers here in the streams library in particular. We're merely using those libraries. And I think Siobhan explored with you the kind of subtleties involved in writing a significant object graph out and getting it back in. We're not trying to solve those problems really. They've been solved for us. We're just using those libraries. Very important though, we figure out a way of testing them. And our testing infrastructure from last week is a little bit involved. Very verbose, I think. It does do the basics, but we might be trying in later labs to simplify this a bit. So what are we doing here? Well, we still have our fixtures that we created. So these are sets of objects that we can use to create interesting scenarios, save them out, read them back, see that we save and read correctly. And we wrote this utility method called populate. And this looks quite awkward now and verbose, but what's it doing? It's creating a set of users, looking up one of the users, creating some activities for that user, looking up another one, creating more activities, adding locations. In other words, it's building an object graph. It's not saving it now, it's just creating an object graph that we think we're interested in testing. Here is a method to test did that population work. So here we are calling populate and then verifying that the API contains state that we've already inserted. Does it contain the users we've created? Do those users contain some of the activities and locations we've inserted? In other words, this test is testing that populate method. Still haven't done any persistence testing, and this would be here. So here now we are seeing if we can find a way of automatically testing our persistence library. So we're doing this in a number of stages. In the first stage, we are making sure there's no test data hanging around that's polluting our test infrastructure. So we're deleting any test data file that might exist. We're then creating our serializer. Our serializer is the little class we're going to use to write out our object graph, write out our pacemaker API state. Then we create a brand new pacemaker and we populate it. And then we call store. So we're expecting now that we've saved the object graph we've just created. We've 5 or 6 users, 2 or 3 activities, half a dozen locations in there. Then we proceed to create a separate pacemaker hooked up to the same serializer, and we load. And now in our final test, we're checking to see, does pacemaker 1 and pacemaker 2 contain the same information. In particular, we're looking at comparing the users from each of the 2 pacemaker instances. Now, it's quite challenging to get your head around that. Pushing it a little bit to extreme, I guess, but it's showing the nature of the tests we would have to write, really, if we were to verify that our serializer was working correctly. 2 completely separate pacemaker objects with completely separate users, but they're identical because one's a serialized version of the other. And that's what our test should prove. If we run the test, again, maybe you've seen this in the lab, we can run all our tests. And we're getting back a green, hopefully, if the tests run. Sorry, I had a failure in here. Just to demonstrate the failure a second ago. Run all the tests again. And again, we're seeing that the persistence tests are here, and they should all be working okay. There might be some residue left over after the test, particularly test data store. And here we can see the object we were populating here. We might have manually inspected this just to make sure we were constructing the tests and the locations as expected. So this file here I'm showing you, it's hard to read here now, is in fact the object graph we created in our populate method, which was here. And you might like to visually verify that if you have the time. Okay, that's our lot for this evening, really. These tests are quite challenging, and I guess they're pushing beyond our knowledge domain that maybe you're comfortable with, which is fine. You would be able to use these tests even if you didn't understand them fully, were you attempting the JSON serialization here in the excellent range. But you should be able to just use the classes we've given you to implement the XML persistence as we've implemented already. Again, I'll remind you that the assignment rubric is to give you an indication of what we'd like you to have a go at. It's to give you an indication of what we consider valuable knowledge. So that's indicated by the percentages and by the grade standard ranges. But of course, you can pursue your own interests as well, and you may be quite happy with an excellent or a good mark, and we'd be happy with that as well. The outstanding range, maybe if you've familiarity with Java coming into this course and you want to push yourself a little bit, then you can have fun in getting an outstanding grade there. Okay, that's our lot for today. Thanks for your attention. Sorry about the little breakdown in communication there on our way through. Just remind you now, we've got 4 labs up and running here. There'll be 1 more lab next week, which will be looking at Maven. You'll have noted Maven here appears mysteriously over here. Well, that will be explained next week. Once those 4 labs are out of the way, then you're ready to have a crack at submitting your assignment. Siobhan will take you through submission guidelines and so on next week, and you've got about 2.5 weeks or so to complete that assignment. We will give you a complete solution to the assignment, and of course we'll be evolving that assignment in interesting directions after the midterm, after you've submitted your assignment and we've tuned the solution. So I hope we're not getting too tired with users and activities and locations, because we're sticking with that model really for our second assignment, which I think you'll find interesting. Okay, we've reached typical end time now is 1.5 hours. I know we've been pushing it to 2 hours for the last few weeks, but this is more typical if you're planning for the future, hopefully. And I will hang around though in the chat room if anybody has any issues. Again, I'll be on the chat room tomorrow afternoon at the usual time, 3 to 5 IST or Irish time. So thanks for your attention, and hope we're making progress on the program and you're getting value out of it. I believe it's going to get quite interesting from now on because the core language features are out of the way, and now we're starting to look at principles, which hopefully moves your knowledge on a little bit further. Just about keeping up with the Java, then if you got this far, there's not going to be an awful lot more new Java syntax to acquire. So you're kind of there now or thereabouts in terms of the core language skills you would need. Okay, I'll sign off then, and I'll be talking to you again in a few weeks' time and chat to you tomorrow as well if you're around for the lab. Thanks again. See you all.